statement here to check out a classic problem. This is a matched pairs test. So let's check it out. This is either a quiz or a worksheet, whatever we want. So I made up a prompt. It's not real data, but we got Mythical Johnny testing two different power saws, Makita and DeWalt. They're kind of well-known brands, DeWalt especially. The saws are made by, it said that already, 10 different pieces of wood labeled A through G are used with each saw cutting the wood and the time in seconds. Here are the results. All right. So what happens classically is you you see the situation on an AP test and you think, all right, do I have two separate lists or are they paired somehow? Like a coordinate pair if you look at my hands. Okay. So uh, piece of wood A was cut twice, like in two different spots of the wood. So the reason that you would want these saws to cut the same piece of wood to compare is because the woods have different density. So you can't just have separate pieces of wood or it wouldn't be fair. So this makes the most sense. So you pair them up. It doesn't really matter what the density of A, B, C, D, all these are. It doesn't make a difference. As long as they're both cutting them, you can do an accurate comparison. So Makita cut the first one in 45 seconds, and the the uh, the other one in 47 seconds is the other one. Okay, so it's one of those things. All right, so the in the end you have these numbers right here, and I'll circle them. -2, whatever they are down here. Let me get that right tool there. Come on now, where is it? I got it already. Okay, this one right here. So -2 means Makita was 2 seconds faster. One means DeWalt was 1 second faster. Zero means they're the same. Okay. None of that's too difficult. Okay. All right. Here's the particulars, the mean, -2.8. So on average, Makita was 2.8 faster. Standard deviation was 3.08. N was 10. Okay. No problem. All right. So let's go down here and let's look at the question. The question is there evidence to suggest that they're different? Different is a not equal to term. Okay. So provide evidence and procedure, no problem. Alpha is oh 05. So I'm going to use mu in a subtitle, mu sub difference. I didn't want to spell out the whole word difference. I put difference equals 0, and mu sub difference is not 0, where mu diff is the real average difference in saw times. Okay, so I'm really down to just one mu because this is my list. These two lists really aren't necessary. It's these two. I mean, this could be 100. This could be 102. It's still a difference of -2. Okay, so the assumptions, representative samples. The lists are representative samples of both sides' capabilities, or the difference is there are at least 100 pieces of wood available, all cuts independent. And this is, and by the way, I made a box plot of this. I made a box plot of this to check for normality. It came out looking something like this. I drew it out. No problem. Now, when you go to Desmos, you're gonna go to t-test. You won't see a matched pairs t-test icon, just see t-test. Put a 0 there. That means there's no difference. Put -2.8 in the tail, and there's your standard deviation. Run the test, and you get a t-score of -2.875 and a p-value of 0.018. That 0.018 is split on two sides. That's why my arrows are there. So this is a reject at 05. It would be a fail to reject at 01. So we have significant evidence to suggest that the two saws are different. They're a little bit different, okay? So Makita being a little bit quicker in this case. All right, now, question B. By the way, on an AP test, that would be a full response. Normally, they wouldn't ask more than that. That's enough to write in 13 minutes if you're writing slow and taking your time and all that kind of stuff. Now, part B. With your conclusion, what error type, one or two, is possible? Describe that error and a possible consequence. Remember, it's a possible consequence because there could be many, many possible consequences. Okay. Okay. Possible type one, the solves are the same, but we thought they were different. That's the description of the of the error. Now, we didn't probably make the error. It's a small, in fact, the probability of a type 1 error is the alpha level. So there's only a 5% chance that we made an error. Okay. So That's pretty cool. A consequence. We recommend Makita because it is quicker, but we never needed to, right? If they're the same, just buy whichever one you want to buy. But if the error would be, we're recommending that, okay? And if you're a reputable company, you might get sued by Makita or something for false, doing the wrong thing. I don't know. Next one. What is the meaning of p-value in context? Okay. So there is a 1.8% chance we would get data this extreme, even if the saws were the same. So if the saws are the same, there's still a chance you would get that kind of data, but it's kind of unlikely. That's why you think that they're different. Okay. And the last one, this is very subjective, but if Makita was 250 bucks and DeWalt was 125, based on your answer in part A back here, again, in part A, you're saying they're different with Makita being better. What would your recommendation be? Which one to buy? You could have a couple answers. I put two sample ones. One, if you're really into the best saw, paying double the double amount to Makita could be worth it since there's evidence to suggest it's better. Or no, double the price may not be worth a 2.8-second average difference, right? May not be worth it. Either one doesn't make any difference, but you got to reference something in the data. Okay. So that is the chapter 9, quiz 2 on matched pairs. I hope that helps. I might take a second here. It might be wise if I went to desmos.com. I'm going to do that, and I'm going to do that one part for you. Okay. So desmos.com, hit the graphing calculator. Let me do the test itself. Remember, you're going to type in the word inference, and then we're going to do a t-test. It doesn't have the word matched pairs t-test. It's just a t-test. Okay. So what were the stats on this? The sample size was 10. The mean, I think, was negative. The negative's just like the dash button, negative 2.8. And the standard deviation, let me look back at my notes, was 3.08. Hope I did that right, by the way. Okay. So you put create test if you remember how to do that. That's kind of cool. So, um, so there, let me get rid of this annotate stuff here real quick. All right. So there's your t-test. We're going to do a significance test. Okay. And I'll do a confidence interval too, just to show you. Probably wise that I do that. So here's the significance test. 0 is that number. That's the default number. And in this case, it's the right one. We're doing to do both. So look how fast that does that. There's your t-score and there's your p-value. It does it really well. Diffuse of freedom is 9. Okay. Now, if you if you were to do a confidence interval, that's kind of cool. If you were to do a confidence interval on this, um, if the alpha level was 0.5 and this was already two-sided, it would be a 95% interval. So it's already there. You can see it. And then that's the interval right there. Okay. So it's somewhere between the Makita saw is somewhere between 5 seconds faster and about a half a second faster. It's pretty close to 0. Zero's not in there. If 0 was in the interval, then you'd have a fail to reject. So, by the way, how do you write out that confidence interval? That confidence interval um, would be the mean, which was negative 2.8 plus or minus. I don't know what T star is for degrees of freedom 9 off the top of my head. I don't really know. And then you're going to multiply that by the standard deviation, which is 3.08 over the square root of 10. So you got to look that up in the charts thing on the AP test, or we have the formula sheet. Okay, 95% at the bottom of the page is 1.96. This is a little bigger. It'll be 2 point something. I don't know what it is. It doesn't matter. I know you can find it. So that will turn into this. And zero's not in the interval. So to repeat, We think the Makita saw could be 5 seconds faster on average, or about zero point 0.6 seconds faster on average. It's really not a big deal for the cost anyway. So, all right. So that should end it. That's pretty cool. I hope that helps. Okay. Um, and that's it. Statman out.